Okay, this is another part of the BGP lab. We're going to see multi-hop. Uh, Action item number 7, capture open packets going to router 3, validate that TTL is 1. So let's capture packets here. And we need to see the open packets. So in order to see that, I'm going to clear IPv summary. This session is up, so I'm going to reset it. Clear IP BGP, this IP address, and see this is open message coming from router 2 to router 3, and notice the TTL is 1, time to leave is 1. So what we want to do now is create a peering between router 2 and router 5, but notice that EBGP was created or designed by default to create peerings between routers that are connected directly to each other in a back-to-back scenario. So in this case, router 5 is not directly connected to router 2. So we have to make this work, we have to make router 2 become a peer to router 5. And let's see what we need. For starters, if I ping router 5 IP address, I cannot reach it. That's because router 4 is in the middle, so I will need to start this config static route. So I will have to add an static route to router 5. And in order to get router 5, I need to go through router 4. So I still cannot ping it, but because I need the static route in the returning direction. So I have to go here and do an static route to reach router 2 through router 4. So now they should see each other. So thanks to the static routing. So let's configure the neighbor on this side. BGP router ID 5.5.5, and the neighbor. This is the IP address of router 2, remote as, and on this side, configure neighbor, the IP address that belongs to router 5 with router 5 autonomous system number. So this still is not working. If we issue this command, you can see that this neighbor is not directly connected. So what we need to do is enable multi-hop. This is, so in order to enable multi-hop, we have to go to router configuration mode and then enable EBGP multi-hop, and let's create a hop count of 10. So I'm over exaggerating here. So 10, And on this side, I'm gonna have to start this capture to see what happens. The three-way handshake is not working, so let's configure multi-hop on the other side. EBGP multi-hop. Then let's see what happens. Okay, I have an open message here, an open message here. And notice the time to leave is 10. So you have to configure multi-hop in order to make this peering successful. So let's go to router 2 and see that it is working now. Let's make router 5 inject some routes, release the boots connected. We have a lot of routes coming from router 5. So show iBGP. So now I have routes from router 5 and it is working now. So let me try to do a ping because the routing is working. So let me ping this one of these networks that live in router 1. So notice that the routing is in place, but however the packets are not reaching router 1. Let's see one of these. Maybe I'm going to ping this one. Sorry, nothing. And let's do a trace route. Nothing. The routing is not working, even though I have a successful route here. So, and this happens because router 4 has no clue about what to do with those routes. If I go to router 4 and I issue show equal route, there is no routing here whatsoever. So the routing will not work because router 4 has no clue of the routes. So I have to make router 4 participate or become aware of the route. So I will have to create an iBGP session between router 4 and router 5. So let's create BGP here. This is the autonomous system. BGP router ID. And I will need to do a neighbor with router 5, which will be an iBGP peering. When the remote autonomous system is the same as mine, this will become a iBGP session. So it is idle. I need to configure this on this side as well. So neighbor 45.4 remote asks same. So now router 4 should have routes. So what happens if I do a ping? That's it. So notice that when you use multi-hop, all the routers that are in between your peers should have the routes. They will not route stuff magically, but in this case, I had to establish an iBGP, an extra iBGP session between router 5 and 4. So router 4 could be able to know what are the routes. Otherwise, each time router 5 tries to communicate, for instance, with router 1, those packets will be dropped here because router 4 is unaware of the routing until we establish an iBGP session between router 4 and router 5. So that's it.